This video is in conjunction with homework 2, chapter 7. You guys are going to do page 1 and you're going to carry out a few simulations regarding a sampling distribution of p hat. What you're going to see when you read the question is that it says that 60% of all people approve of gambling. That's going to be called 0.60, and that's going to be called a parameter because that is the population number. So keep in mind that that's the true proportion of people that they're claiming that approve of gambling, the true proportion of all people who approve of gambling. You're going to use that information to use your key, make your key, and you're going to set it up, and then you're going to describe the design like we did in class, and then you're going to carry out for 5 trials. Each line you're going to use a separate trial. You're going to find the p hat for each one. And it says it's going to be a sample of size 10. So you're only going to have to read out 10 digits from each line and get the p hat for each line. So you're going to find the p hat for line 1, 2, 3, 4, and 5. And then eventually you'll find the mean of all the p hats like we did in class. Then you're going to go to page 2. So today we're going to talk a little bit more about finding the sampling distribution of p hat. What you just did was you calculated the sampling distribution of 5 separate trials of p hats. So imagine if we had graphed all those. We would have put on the x-axis the values of p hat and you would have plotted them. If we had done this infinite times and plotted all the values of p hat, that would be called the sampling distribution of p hat. So we've talked about it now for the last few days. It's all possible values of the sample proportion p hat calculated from simple random samples of the same size and taken from the same population. Okay, so you just did this when you did the previous page. You did samples of size 10 and you did simple random samples because you were using a random number generator and you were finding the p hat. So you found the p hat, found the p hat, found the p hat. If you had done this infinite times and plotted all the values of p hat, that would be called the sampling distribution of the sample proportion p hat. Now in the past, when we were describing a distribution, we would have to use SOCs, which we mentioned the other day is shape, outliers, center, and spread. And if we were given a picture like this in the past, we would just kind of look at it and we would describe what we see. So it would say the shape is approximately normal for all the p hats here. This was asking about the people who have watched Survivor, and specifically the proportion of people out of 100 people who have watched Survivor. So they graphed all of them here. The outliers, there's really none. The center looks like it's centered around 0.37. I'm going to put a squiggly equal sign because it's approximately. And the spread, we don't really know what it is. Okay, we could say that it goes from this number here, 0.22-ish, to this number here, 0.5. But we don't really know the exact value of sigma yet, okay? So this was just kind of like a surface level SOCs. We did shape, outlier, center, spread, just by looking at it. But there's actually a real way of calculating the value of the mean of all the p hats and the standard deviation of the p hats. And that actually is on the reference table, okay? So we can go to our reference table and we can use formulas that are going to help us here. So this is the more official route of doing SOCs for a sampling distribution of p hat. Let's start with the mean. The center in SOCs, the C for SOCs stands for center, and we can use median or mean. In this case, we're going to use mean. And the mean of all the p hats, there is a formula for this. So I want you to write down formula sheet. And I showed it to some of you guys yesterday or last week, I should say. So if you're looking on your reference table, you're going to scroll to number 3. Roman numeral 3 is called sampling distributions and inferential statistics. And right here it says continued, you're going to look at p hat, and here is the mu p hat. So mu sub p hat we're going to use, and sigma p hat here. The mean of all the p hats should equal p, the true proportion of the parameter of the population. Mu sub p hat equals p. And we said that that is called unbiased. Unbiased if the center of all the p hats is at the true population parameter. If it's centered at the true parameter, it's called unbiased. So mu sub p hat equals p. That's from the formula sheet. And then the other one is sigma p hat. That's also on the formula sheet right next to the mu. It's right here, spread. Sigma p hat equals p times 1 minus p over n. Take the square root of that, okay? So let's write that down over here. Square root of p times q, or 1 minus p over n, okay? So this is center and spread for you. Spread. Remember socks, that's the S in spread. So as you can see, these two formulas are right off the formula sheet. Now, there are some rules of thumb that we're going to have to check in order to proceed with a couple of things here. The first one is we're not allowed to proceed with this formula for standard deviation unless one of these rules is met. And that says that 10 times n, which is 10 times the sample size, has to be less than the population of interest. So the sample must be 10% or less than the population of interest. If this rule is met, then we are allowed to proceed with this formula for sigma p hat, which we stated above. That is the first thing that we have to check before we use that formula. Now we're going to do an example. I'm going to show you what I mean. So looking at example 1, it says about 84% of people at this large high school use a backpack every day. That is considered P, the true parameter. So let P equal the true parameter at 0.84. It's the true proportion of all the students at the school who use a backpack. Okay, that's important to note. So we've already defined the parameter and the population of interest here. And now it says we're going to take a sample of 100 students, that's n, and we're going to proceed and find the p hat, which is the sample proportion for that sample of 100. So we would find the sample of 100, ask them how many of you use a backpack, find the proportion out of 100, and that's called p hat because it would be from a sample, and then we would plot it. So basically this is saying what is the mean of all the p hats. So if we had plotted all the values of p hat, found the sample, find the p hat, found the sample of 100, find the p hat, found the sample, found the p hat. If we had plotted all those, what would be the mean of all the p hats? And on that formula sheet, remember we said on the last page, mu sub p hat equals p. Right here, mu sub p hat equals p. So the mean of all the p hats will equal the true proportion p, which is 0.84. That's that. That's the center. All right, that's that. Now we want to do standard deviation. We want to talk about spread. So for us to do the formula for spread, which is sigma p hat equals square root of p times 1 minus p over n, before we do that, we have to check that rule of thumb that we said before. So we have to check that 10 times n is less than the population of interest. Okay, so n we said above was 100. So we want to do 10 times 100, which is 1,000. And is that less than the population of interest? So you have to specify who the population of interest is. And we said above, it's all the students at the school. So you have to write that down. And also you have to write down actually doing the math of 10 times n. You have to do 10 times 100, which is 1,000, and show that indeed it is less than the population of all the high school students at this school, which in this case in Valley Stream Central, we have about 3,000 kids in our school, so this is definitely met. And once this is met, you're allowed to proceed with this formula over here, which says that the standard deviation of p hat is equal to the square root of p times 1 minus p over n. So we're going to just substitute in here. Okay, so we're going to do 0.84 times 1 minus 0.84 over n, which is 100. We're going to get our standard deviation. Okay, so let's do it now. I think I put it in before here. Here it is. 0.84 times 1 minus 0.84 over 100, we get 0.037. So this is going to be the spread. Okay, so we already now have center and we have spread. And that is important because we're crafting this shape, center, spread so we can proceed, okay? So we have center, which is the mean, we have spread, which is the standard deviation, and now we're going to talk about shape. So in the example that I showed you before with all the dot plot, we saw we could just kind of look at it and we could find the shape of the dot plot by looking at it. And we saw that it was approximately normal. You see on this one here, we just looked at it, we said, oh, it's approximately normal, and we were done with shape. But what if we don't have the picture? Well, we have to do another rule of thumb. And this rule of thumb says, in order for us to assume, we can assume, that something is approximately normal, we have to check that the sample size is large enough. So the large counts condition is check that n times p, which is n, the sample size, times the proportion from the parameter, is at least 10. If this product is greater than or equal to 10, then that means the sample size is large enough that the data will be approximately normal for the sampling distribution of p hat. And you have to also check n times q, or 1 minus p, is at least 10. If both of these are met, then thus the sampling distribution of p hat will be approximately normal. Okay, so you can't just assume that it's going to be approximately normal unless this is met. That says approximately normal, by the way. It's got a little merged together. So we're going to check this now. If it's met, then we can proceed with Z procedures, or normal bell curve procedure. So let's do it now. N times P greater than or equal to 10, I don't know. And N times Q greater than or equal to 10. If this is met, then the sampling distribution will be approximately normal. N was 100, P was 0.84. 100 times 0.84 is equal to 84. Is that bigger than 10? Check. It is. That's good news. Now we're going to do N times Q. 100 times 1 minus P, which is 16. Is that bigger than 10? Yes. So if these two are met, then that means N is large enough that the large counts condition is met. So you say, thus, the sampling distribution of p hat, which is all the p hats graphed out, is approximately normal. And we are allowed to proceed with using Z procedures, which is bell curve stuff that we've been doing all year. So once we have shape, we have center, we have spread, we just did shape. That was part C. We did center in part A, which was mean, and we did spread, part B. Then we're ready to culminate into this last question here, part D. So it says, what is the probability, big P, that a random sample of 100, sample size n, will give a sample proportion, P hat, at least 86%. You guys, at least means greater than or equal to 86%, and then the sample proportion they're asking me about, so that's going to be p hat. Okay, so we just came off of the binomial probability unit, and now in this unit, because we checked that it is approximately normal, we're going to apply Bell procedures to find the probability, and we're going to go back to normal probability. So you're allowed to draw the bell curve here. Why? Because we checked that it was approximately normal. What I'm drawing here is going to be the sampling distribution of p hat, which means that if I were plotting this out, all the values of p hat would go on the bottom here on the x-axis, and it would be centered at the mean of all the p hats, which, if you recall, if you go back to part A of this question, the mean of the p hats will be centered at 0.84. So you want to center it at the true parameter p, which is 0.84. Okay, so that's this. And now they're asking me what is the probability that the sample proportion, which is called p hat, of a sample of 100 will be greater than or equal to 86%. So somewhere to the right here, you want to put a line, label it p hat equals 0.86, and we want to know the probability that the sample statistic will be as extreme or more extreme than the sample statistic of p hat equals 0.86. So basically you want this area here under the curve to the right. So there are two ways that we can find the area under a normal curve. We could either use a z-score. You guys know the formula is value minus mean divided by standard deviation, or we could use normal CDF. I'm going to show you both. So in the past, the value was x, and the mean was mu, and the standard deviation was sigma. Now we're going to do everything in terms of p hat. So instead of x, we're going to do p hat, which is here, okay, which is 0.86, minus mu p hat, so instead of mu p hat over sigma p hat. Value minus mean over standard deviation. So p hat minus mu p hat over sigma p hat. So the p hat value was 0.86 minus the mean was 0.84 over standard deviation. The standard deviation of p hat we calculated in part B was here, 0.037. So that's going to go in our denominator of our z-score. Okay, so now we're going to enter this. We're going to find our z-score, and that's going to be the area, that's going to be the critical value here. Then on our table, we would go to the table A, find the area to the left, and subtract from 1 to get the area to the right. So I did this on my calculator, and I got a z-score of 0.54. And then I would find the area to the left on table A, and I would subtract from 1. So I found 0.54 on my table, and I see here my area is 0.7054. That is actually the area to the left. And then I would do 1 minus 0.7054 to get my area to the right. Okay, so let's do that now. And that's going to be my answer, 0.2946. This is the answer to the question using Z procedures. Now I'm going to show you how to check it using our normal CDF. So normal CDF, you guys know you press second bars, you go to number 2. You're going to put in the lower bound, the upper bound, the mean, and the standard deviation. The lower bound is 0.86, upper bound is infinity. The mean was 0.84, which we calculated. Standard deviation 0.037, which we calculated. And if you hit paste, you're going to get the answer of 0.2944. So if you are using the calculator method, you want to state that it is normally distributed. And you want to say the mean, the standard deviation, the lower bound, the upper bound, and you want to write the notation, okay? So the mean was 0.84, the standard deviation was 0.037, the lower bound was 0.86, the upper bound was infinity, or 1 EE99, and then the notation was p hat greater than or equal to 0.86, and then you could write the answer from the calculator. So I got 0.2944 for this, which is slightly different than the other method, and then technically you're done and you write from calc. All right, so this question, it culminated in finding a z-score and the normal probability for the sampling distribution of p hat, but you needed the separate components of the mean, which is the center, the spread, which is the standard deviation. You needed to do the rules of thumb in order to get there, and understand that you can't apply the normal curve procedures unless it is normally distributed, and that means you have to check those rules of thumb. All right, it's a lot. Thank you for listening.